So here we're going to look at calculating percent yield after we've calculated theoretical yield. So anytime we're calculating theoretical yield, we need to use our limiting reactant. So first we need to find our limiting reactants. So we have two different reactants. We have 49 grams of HPO4, which is phosphoric acid, and we have 112 grams of potassium hydroxide. So those are our two reactants. We need to figure out how much each one will produce, and the lowest one will be our theoretical yield. Now, our theoretical yield of what? Okay, so we're given information about water. Okay, so we need to figure out the theoretical yield of water. And write down the molar mass of water here. It's 1.01 times 2 plus 16, so that's 18.01. So as you can see here, I've already figured out all of my molar masses because I know I'm going to need each one of them. And we'll just start from the first reactant. So we're going to start with the phosphoric acid, which is H3PO4. And we've got 49 grams of the H3PO4. So first we're going to cancel out the grams. So I'm going to put the molar mass, 97.93 grams per 1 mole. And now that that cancels out grams, and we're at moles of phosphoric acid. So now I want to cancel out my phosphoric acid and convert that to water. Okay, so I'm going to cancel the H3PO4. I'm going to pull it exactly like I see it here with one is the coefficient. And then I'm going to plug in my water. And I see it here with a 3 as a coefficient, so that goes on top. Okay, and so now that cancels out the phosphoric acid, and it leaves me with moles of water. Now the question is in grams of water, so we're going to go one more step. And we're going to put the molar mass of water here over 1 mole. So that cancels my moles and leaves me with grams. So now if I multiply everything across the top, so I've got 49 times 3 times 18.01, and that comes out to 2,647.47. I'll multiply everything on the bottom. 97.93 times 1 is 97.93. So now I'm going to do top divided by bottom. So 2,647.47 divided by 97.93. And that's 27.0. And that's grams of water. Okay, so that's how much water can be produced from the phosphoric acid. Next, we're going to see how much grams of water can be produced from the potassium hydroxide. So to start with, I have 112 grams of potassium hydroxide. So I'm going to start with that. One mole over the molar mass of the potassium hydroxide, which is 56.11. Then I want to cancel the potassium hydroxide, and so I'm going to pull it from here, 3 KOH. And then I'm looking for water. So I'm going to put the 3 moles of water on top. And last step, the molar mass of water. You can multiply everything on the top. So 112 times 3 times 18.01, 6,051.36 over multiplying everything on the bottom, 56.11 times 3, 168.33, 6051.36 divided by 168.33 gives me 35.9 water. Okay, so now our theoretical yield is going to be the one that is the lowest amount that could be produced. So 27 is less than 39.5, so this is our theoretical yield. So our theoretical yield is 27.0 grams of water. That's how much theoretically could be produced. Now we're going to find our percent yield. So to find our percent yield, we need to look at our actual yield. So right here in the word problem, our actual yield is given. What is actually produced was 25 grams of water. So that's our actual yield. And our formula for percent yield is actual over theoretical times 100. So that 25 grams is going to go over 27 grams. And then we're going to multiply that by 100. So I'll put that in the calculator. 25 divided by 27 times 100 is 92.6. And now we've calculated the percent yield. And to do that, we needed the theoretical yield. Oh, we haven't said what the limiting reactant is. So the limiting reactant, okay, is going to be the reactant that led to the theoretical yield. So here's our theoretical yield. We got to go back to the start, and we see here that the reactant that we used to find that lower theoretical yield was the phosphoric acid. So the limiting reactant is the H3PO4. So 3 answers here: limiting reactant, theoretical yield, and percent yield.